Another thing we'd like to look at in 6.1 are rational inequalities. These are inequalities involving rational expressions. So we're just going to look at one, and along the way we'll pick up the procedure for solving them. So we're going to solve this inequality. Let me read it here. We have x divided by x squared minus x minus 6 is less than or equal to negative 1 over x squared minus x minus 6. Same denominator there. All right, now if you recall the way that we solved polynomial inequalities, we would factor, find the zeros, take the x-axis and split it into intervals, and then test each interval to see whether that value solved the inequality. And then if it did, that interval would solve the inequality. If it didn't, we'd have to throw that interval out. The procedure for rational inequalities is very much the same. We're still concerned with where the zeros are, but we also have to take into consideration that the rational function could change sign if we go over a vertical asymptote. So along with the zeros, we have to also break up the x-axis in terms of its vertical asymptotes as well. All right, so with that in mind, let's solve this. And the first thing we want to do is get everything on one side and put everything under the same denominator. Now, since both of the denominators are the same, this is going to be rather straightforward. We can add this term to the other side, and we'll get x over x squared minus x minus 6 plus 1 over x squared minus x minus 6 less than or equal to 0. Now we want to set everything on one side less than or equal to 0, all right, as we did with the polynomial inequalities. Okay, now these have the same denominator, so there's nothing we need to do to get the same one, so we can just combine them. X plus 1 over x squared minus x minus 6. Okay, now we need two things. First, we need the zeros, so you clearly see that's going to be negative 1. And then we need the zeros of the denominator. That's where we have vertical asymptotes. So let's go ahead and factor this. We've got x plus 1 over x, and looks like minus 3 plus 2. That works. Outside plus 2x, inside minus 3x, minus x, and then minus 3 times plus 2 is minus 6. Less than or equal to 0. All right, so the values that we have to take into consideration are x equals negative 1, x equals 3, and x equals negative 2. All right. So let's draw our real line, and we will write down these values. So there's a vertical asymptote here, negative 1, that's a 0, and then x equals 3. All right, so we have 1, 2, 3, 4 intervals, and now we'll test a value in each one in the original inequality. So let's start over here. Let's look at, I don't know, x equals negative 3. Okay. So we have negative 3 over negative 3 squared, which is 9, minus a negative 3, plus 3, minus 6, less than or equal to negative 1 over 9 plus 3 minus 6. Okay, 12 minus 6, 12 plus 3 minus 6, 12 minus 6 is 6, so we have negative 3/6 less than or equal to negative 1/6. Is that true? Yes. So this interval is in the solution set of the inequality. All right, let's pick a number between negative 2 and negative 1. So we're just going to have to pick negative 1.5. See what we get. So we have let's write that as a improper fraction, make it easier to deal with. Okay. All right, so we have negative 3/2 over 9/4 plus 3/2 minus 6 less than or equal to -1 over, same thing, 9/4 plus 3/2 minus 6. Okay. Fractions and fractions, I don't like that. Let's go ahead and multiply everything by, let's see, 4/4. Don't have to worry about that anymore. So we're going to have -6 over 9 plus 6 minus 24. Over here we have -4 over 9 plus 6 minus 24. Okay, so we have -6 over 9 plus 6 minus 24. Let's look at that. That's -6 over 15 minus 24 is -9. Less than or equal to -4 over -9. So is 6/9 less than or equal to 4/9? And the answer to that is no, that's false. So this interval must be excluded. Let's check a value between -1 and 3. So let's try 0. So if we plug in 0, we get 0 on the left-hand side. And on the right-hand side, we get -1 over -6. That's 1/6, which is a positive number. So this is true. So we will include this interval. And then we need a number greater than 3. Let's try 4. So we have 4 over 16 minus 4 minus 6 less than or equal to -1 over 16 minus 4 minus 6. So -4 minus 6 is -10. So we have 4/6 less than or equal to -1 over 6. -1/6 is not greater than or equal to 4/6. So this is false. And so we will exclude this interval. All right. So we have intervals from -∞ to -2, -1 to 3, and we have to take into consideration the type of inequality. We have a non-strict inequality. So at this 0, that is the 0 of the numerator, we will have to use a bracket. Now, at the values that are the vertical asymptotes, so here and here, we'll always use parentheses because the function is, this function or these values are simply not defined there. We have the vertical asymptotes. And here we have a 0. So that could be, that will be a part of the solution set. Okay, so we go from -∞ to -2, parentheses because we have the vertical asymptote there, union, and at -1 it starts, but we include it because we have a non-strict inequality, to 3. Now 3 is a vertical asymptote, so we use parentheses. So the solution to this inequality is -∞ to -2, union, bracket, -1 to 3.